welcome back to my channel. Today we will discuss on VIP questions, chapter 9, simple harmonic motion. For questions number 1, the displacement x of the particle at time equals to t is simple harmonic motion is given by the equations where they give you x is equals to 10 sine 20t. So determine the length of the pendulum so that it has the same period as the particle. Okay, so we want to find the period. Okay, so the period for the pendulum we know that is equals to 2 pi over L over G. Okay, so we want to find what is the length here. Okay, so before that the question already mentions that the period of the pendulum is actually same period as the particle. Okay, so from here we know that x equals to a sine omega t. So we compare the equations, we know that the omega is equals to 20 and omega also equals to 20 over t. So our t here period is equals to 2 pi over 20. Okay, so this is the first equation and this is the second equation. So we know that because the period is same, so we can let equation 1 equals to equations 2 where 2 pi over 20 is equals to 2 pi third L over G. Okay, so 2 pi and 2 pi we can cancel and then we square for both sides. So we will get 1 over 20 square equals to L over G. Okay, so L is equals to 9.81 over 20 square. So the final answer that we will get is equals to 0.0245 meter cm. Okay, so we can convert it into 2.45 cm. Okay, so the answer, the nearest one is D. Okay, questions number 2. Okay, given that x is equals to 4 cos 1.33t plus pi over 5. Okay, so the equations give us is x equals to 4 cos 1.33t plus pi over 5. Okay, so what is the value of the velocity and also accelerations of this particle when t equals to 1 second? Okay, here they give you the displacement, so we want to find the velocity. We can use v equals to dx over dt. We differentiate 4, we copy back, we differentiate cos, you will get negative sine. Okay, we differentiate omega t, you will get omega, so omega I write here 1.33 and you copy back 1.33t plus pi over 5. Okay, so when t equals to 1 second, you substitute negative 4 times 1.33 sine 1.33 times 1 because t is 1 second plus pi over 5. So the velocity that we will get is equals to negative 4.9 meter per second. Okay, next we want to find the accelerations, where acceleration is equals to dv over dt. So we copy back 4, negative 4 times 1.33. Okay, so we differentiate sine, you will get cos. You differentiate omega t, you will get omega. So omega here 1.33, I squared it up. So we copy back 1.33 t plus pi over 5, where t is equals to 1. Okay, so if we press calculator, we will get negative 2.67 meter per second square. So remember, this value actually still in radian. So you need to change your calculator in the mode radian. Okay, remember to change the calculator in radian mode. So the nearest answer is B. Okay, the next question, question number 3. An object of mass 0.1 kg is connected to a helical spring which undergoes simple harmonic motion of the period 1 second. Determine the new mass if the period of the oscillation is to be reduced to 0.5 seconds. Okay, so here what the informations we have here is we have the mass equals to 0.1, we have the period 1 is equals to 1 second. Okay, and the period 2 is equals to 0.5 seconds. So we want to find what is the mass. the new mass if the period of the oscillation is reduced to 0.5 second. Okay, so for the spring, tension for spring is equals to 2 pi square root m over k. We know that the period is directly proportional to sub m, so we can write T1 over T2 equals to square root m1 over m2, where T1 is equals to 1 second, T2 is equals to 0.5, m1 is equals to 0.1 kg, and m2 is the value that we want to find. Okay, m2 will equals to 0.1 times 0.5 square, so therefore the answer that we get is 0.025 kg. Okay, so the answer is C. Okay, questions number 4. The displacement of the particle oscillating in simple harmonic motion. So they give you the equations where the x is equals to 4 sine 10 pi t, and they ask you to find the maximum velocity of this particle. Okay, so if you compare x equals to a sine omega t, we know that a is equals to 4, and here already mentioned in cm, so it's 4 cm, and the omega is equals to 10 pi. Okay, from the equations we get 10 pi. Okay, so what is the equation for V maximum? Yes, V maximum is equals to A omega. So we just substitute A is equals to 4 cm, omega is equals to 10 pi. So the answer is actually 40 pi, or we can write it as 125.7 cm per second. Okay, so cm because just now we substitute 4 in cm. Okay, so the answer is A. Okay, questions number 5. A block of the mass 100 gram is suspended from a vertical helix spring, and the spring constant K is equals to 20 Newton per meter. The block is pulled at a distance 2 cm from the equilibrium positions of x equals to 0 cm. So determine the period of the oscillation. So we know that T for the spring is equals to 2 pi square root m over k. Okay, so we just substitute where the m here is equals to 100 grams, so 100 grams is equals to 0.1 kg, and the spring constant is equals to 20 Newton per meter. Okay, so if you press calculator, the period for the spring, we will get 0.44 second. Okay, so the answer here will be B. Okay, last questions here is the questions related to the kinetic energy. So they give you the equation x equals to 2 sine 2t plus pi over 2. Determine the value of kinetic energy when t equals to 2 seconds and the mass of the object is 0.5 kg. Okay, so we know that kinetic energy is equals to half m omega square a square minus x square. So we substitute half m is equals to 0.5. Okay, omega we don't have, but we can compare the equations here where x is equals to a sine omega t plus phi. So we know that omega is actually 2. So we substitute here 2 square. Okay, amplitude here is actually A is equals to 2. So I substitute here equals to 2 square minus x. Okay, so we need to find the displacement when t equals to 2 seconds. So we substitute into the equations where when t equals to 2 seconds, okay, x is equals to 2 sine 2 times 2 plus pi over 2. Okay, so remember here we must change it into mode radian. Okay, so if you press calculator, the displacement when t equals to 2 seconds, we will get negative 1.307. Okay, so we substitute into the equations where x when t equals to 2 seconds is equals to negative 1.307 square. Okay, so if you press calculator, we will get 2.29 joule. Okay, so the answer is equals to B. Okay, so that's all for this chapter. Okay, please watch on the next video. We will discuss on VIP questions chapter 10. Okay, see you. Bye.